Question 1. To illustrate this point, Mr. Ramirez is troubleshooting a walk-in freezer that intermittently fails to maintain its set temperature. Upon investigation, he finds frost buildup near the TSV and notes fluctuating superheat readings. The compressor amp drawer is within normal range. Based on his findings, which replacement part is most likely the root cause of the issue? A. Defective compressor windings. B. Malfunctioning evaporator fan motor. C. Sticking thermostatic expansion valve (TXV). D. Oversized liquid line filter dryer. Answer. Correct answer. C. Sticking thermostatic expansion valve (TXV). Explanation. A sticking EXV can cause inconsistent superheat and improper refrigerant flow, leading to frost buildup and poor evaporator performance. Compressor and motor function appear normal, and an oversized filter dryer typically causes minimal issues unless fully clogged. TXV issues commonly manifest as intermittent underfeeding or hunting. Reference. RE Guideline and HVACR refrigerant flow controls. Question 2. Based on the information, a technician installs a SC motor in place of a failed Ecken blow-up motor without updating the control board or circuitry. The system starts but quickly trips on overload. What is the most plausible explanation? A. PSC motors require variable voltage inputs. B. The motor was wired for reverse rotation. C. The Ecken motors have integrated controls incompatible with PSC. D. The blower wheel size is incompatible with PSC motors. Answer. Correct answer. C. Ecken motors have integrated controls incompatible with PSC. Explanation. Ecken motors have built-in logic and variable speed capability. Replacing them with PSC motors without modifying control logic or wiring leads to electrical mismatch and overload. PSC motors lack variable speed features, making them unsuitable without rewiring and control board adjustments. Reference. NATE Course Study Guide. Motors, Air Movement, or Assist Motor Replacement Guidelines. Question 3. In light of recent developments, Sophia, a parts specialist, receives a call from a field technician requesting a E or a system converted from R22 to R407. Which factor is most critical when selecting? A. Compatibility TXV. A. The tonnage rating of the condenser coil. B. The operating pressure of the compressor. C. The valve's refrigerant compatibility. D. The suckling level of the liquid line. Answer. Correct answer. C. The valve's refrigerant compatibility. Explanation. ESVS must match the refrigerant's pressure temperature characteristics. R407 differs from R22 in glide and boiling point, and using an R22 rated TXV may cause inaccurate superheat control, subcooling, and system tonnage effect sizing, but compatibility is paramount. Reference. RE Standard 750. EPA Section 608 Refrigerant Substitutes. Question 4. Through the lens of customer service best practices, Marcus is assisting a homeowner selecting a new digital thermostat. The customer wants to replace a mechanical thermostat in a heat pump system but is unaware of the WABU terminal function. What should Marcus prioritize during the selection? A. Ensuring the new thermostat supports dual fuel systems. B. Verifying compatibility with emergency heat and reversing valve control. C. Selecting Y-enabled model for ease of access. D. Choosing thermostat with outdoor temperature sensors. Answer. Correct answer. B. Verifying compatibility with emergency heat and reversing valve control. Explanation. For heat pump systems, the MABU terminal controls the reversing valve. Incompatibility can cause heating in cooling mode and vice versa. Emergency heat functionality is also essential. Y-and sensors are useful but not critical for core system operation. Reference. RCS Thermostat Installation Guide. A Honeywell technical documentation. Question 5. While examining a commercial ice machine that repeatedly shuts down during peak demand, technician Alina suspects a refrigerant restriction. The suction line shows frost near the evaporator inlet and low pressure. Which component is the most likely culprit? A. Oversized expansion valve. B. Clogged filter dryer. C. Faulty defrost timer. D. Worn out compressor valves. Answer. Correct answer. B. Clogged filter dryer. Explanation. A clogged filter dryer restricts liquid refrigerant flow, causing low suction pressure and inlet frosting. An oversized TXV would overfeed, not restrict. Defrost timers and compressor valves cause other symptoms, not flow blockage. Reference: HRConquer troubleshooting refrigerant restrictions. ASHRAE Refrigeration Handbook. Question 6. Considering the evidence, a technician reports low airflow in a ducted split system after blow motor replacement. The replacement was the correct horsepower and voltage, but the motor frame was longer. What should be checked first? A. Incorrect wiring of high-speed tap. B. Duct leakage near return side. C. Fan blade positioning and clearance. D. Supply plenum static pressure. Answer. Correct answer: C. Fan blade positioning and clearance. Explanation: motor frame size affects how far the fan blade sits in the housing. Incorrect blade depth reduces airflow drastically. Wiring, leakage, or static pressure may affect performance, but positioning is most often overlooked. Reference: a CAM Manual D. Air distribution. OC's motor installation best practices. Question 7. From a practical standpoint, technician Brian is testing an air-cooled condenser during hot ambient conditions. The discharge pressure is abnormally high. Which of the following parts should he check first? A. Compressor crankcase heater. B. Condenser fan motor and blade. C. Liquid line solenoid valve. D. Evaporator temperature sensor. Answer. Correct answer: B. Condenser fan motor and blade. Explanation: a failed or underperforming condenser fan during high ambient results in reduced heat rejection and elevated head pressure. Solenoid valves and sensors don't impact discharge pressure directly. Crankcase heaters prevent slugging, not high discharge. Reference: HRConquer Condenser Diagnostics Guide. ASHRAE System Performance Fundamentals. Question 8. When evaluating the merits of motor technologies, the contractor must decide between using a permanent split capacitor (PSC) motor or an electronically commutated motor (ECM) in a new air handler. What is a significant advantage of ECM motors? A. Lower initial cost. B. Simpler wiring configurations. C. Variable speed and energy efficiency. D. Greater resistance to power surges. Answer. Correct answer: C. Variable speed and energy efficiency. Explanation: ECM motors adjust speed based on system load, improving comfort and energy savings, especially with variable airflow needs. That they cost more initially and are more complex, they outperform PSC in life cycle efficiency. Reference: motor efficiency regulations. The CPS versus PSC comparison guide. Question 9. In what ways can misidentifying a dual-run capacitor lead to equipment failure? A parts counter assistant incorrectly supplies a capacitor with equal off ratings on both terminals for unit that requires unequal ratings. A. Only the compressor will fail to start. B. The fan motor will overspeed and burn out. C. Both compressor and fan may operate erratically. D. The capacitor will auto-adjust to correct rating. Answer. Correct answer: C. Both compressor and fan may operate erratically. Explanation: dual-run capacitors support both fan and compressor. If incorrect off values are supplied, each motor receives improper phase shift, reducing torque and risking burnout or failure to start. Capacitors do not adjust themselves. Reference: NEMA Capacitor Selection Guide. OCSA's Electrical Component Handbook. Question 10. Given the circumstances, customer Isley wants to replace a failed contactor in her packaged rooftop unit. She provides the coil voltage and FLA, but not the number of poles. What should the HVACR parts specialist clarify before supplying the part? A. Compressor manufacturer brand. B. Contactor mounting style. C. Number of poles or stages of operation. D. Type of terminal connectors. Answer. Correct answer: C. Number of poles or stages of operation. Explanation: contactor pole count determines how many circuits are switched. A one-pole versus two-pole contactor affects load distribution and operation. Coil voltage and FLA matter, but pole count is essential to ensure compatibility. Reference: HRConquer Electrical Components Manual, the NEC 430.83 for contactor use. Question 11. With respect to troubleshooting strategies, Jacob is assisting the technician who reports intermittent tripping of the high-pressure switch on a ductless mini-split system during mild weather. The refrigerant charge and filter cleanliness have been verified. What component should Jacob suggest checking next? A. The indoor blower speed settings. B. The reversing valve solenoid. C. The condenser fan motor operation. D. The expansion valve sensor bulb. Answer. Correct answer. C. The condenser fan motor operation. Explanation. A sluggish or failed condenser fan can cause excessive head pressure, especially in systems relying on air movement for heat rejection. Even with correct charge, heat cannot dissipate efficiently. This leads to high pressure switch activation. Indoor blower and ESV effect evaporator side and reversing valve issues would manifest differently. Reference. ASE's split system troubleshooting. ASHRAE HVAC systems and equipment. Question 12. To better understand how metering devices function, consider a technician requesting a replacement capillary tube for a low-temperature freezer application. What critical factor must the parts specialist verify before providing the correct cap tube? A. The external equalizer line pressure. B. The line set diameter. C. The tube's length and internal bore diameter. D. The ambient temperature range. Answer. Correct answer. C. The tube's length and internal bore diameter. Explanation. Capillary tubes are precision metering devices. Refrigerant flow is highly dependent on bore size and length, affecting system pressure and superheat. Equalizer lines apply to SES, not cap tubes. Ambient temp is secondary. Misidentification leads to overfeeding or underfeeding, risking compressor damage. Reference. ASE's metering devices manual. Emerson application guidelines. Question 13. From multiple perspectives, why might the scroll compressor be chosen over a reciprocating compressor in a rooftop unit? A. Scroll compressors are easier to rebuild in the field. B. Scroll compressors operate more quietly and efficiently. C. Scroll compressors require less oil for lubrication. D. Scroll compressors can reverse direction for defrost. Answer. Correct answer. B. Scroll compressors operate more quietly and efficiently. Explanation. Scroll compressors have fewer moving parts, smoother compression cycles, and better part load efficiency than reciprocating compressors. They are not field serviceable, unlike recips. Reversing defrost applies to heat pumps, not scroll-specific features. Reference. RE scroll compressor comparison. ASE's compressor fundamentals. Question 14. Upon closer examination, Alvarez notices that multiple contactors returned under warranty have coil burn marks. All were installed on systems with proper voltage and flow ratings, which overlooked details should be investigated. A. Loose terminal screws. B. Contact point alignment. C. Presence of voltage spikes or harmonics. D. Wire insulation temperature rating. Answer. Correct answer. C. Presence of voltage spikes or harmonics. Explanation. Voltage spikes or harmonic distortion can damage coils by stressing insulation and generating excess heat, even when voltage and load match. Poor power quality causes premature failure. Loose screws or alignment may cause arcing, but not coil burns. Reference. ESDD 519. Harmonic control. It receives electrical component failures. Question 15. The most significant aspect of selecting a replacement condenser coil is ensuring which of the following: A. The number of rows and fins per inch match the original. B. The coil includes built-in sight glass and dryer. C. The tubing material is replaced with aluminum for cost. D. The mounting bracket location is within plus 1 inch. Answer. Correct answer. A. The number of rows and fins per inch match the original. Explanation. Heat transfer capacity is directly tied to coil design. Rows and FPI determine surface area. Misaligned mounting or missing dry side glass can be adjusted, but incorrect thermal performance leads to inefficiency and cycling. Aluminum is cheaper but not always suitable. Reference. A CAM Manual S. It receives coil replacement guidelines. Question 16. Historically speaking, what was one of the driving forces behind the shift from R22 to R400 TINA in residential systems? A. The energy efficiency of R400 TINA was triple that of R22. B. R400 TINA operates at lower pressures than R22. C. R22 was phased out due to ozone depletion potential. Or D. R400 TINA contains no hydrocarbons, making it safer. Answer. Correct answer. C. R22 was phased out due to ozone depletion potential. Explanation. R22 is a hydrochlorofluorocarbon HEFC with OP. Under the Montreal Protocol, its production was phased out globally. R400 TINA has zero OP but operates at higher pressures, requiring specific components. Energy efficiency depends on system design, not refrigerant alone. Reference: Epiclean Air Act Section 608 Montreal Protocol. Question 17. The prevailing attitude toward customer interaction suggests that when a technician calls requesting a 2-ton compressor, the parts specialist should first A. Ask for the model number of the original compressor, B. Confirm if the customer wants R22 or R400 TINA, C. Recommend upgrading to scroll compressor, D. Cross-reference the condenser brand and serial number. Answer. Correct answer: A. Ask for the model number of the original compressor. Explanation: model numbers are critical to ensure exact match for electrical specs, displacement, mounting, and refrigerant type. Ton rating alone is not enough. Cross-referencing can follow, but model data is primary. Upgrading or switching refrigerants requires system redesign. Reference: HRConquer parts identification training, open compressor cross-reference tools. Question 18. During the process of setting up an online parts database, HVAC wholesaler Greg must decide how to organize evaporator coil inventory. What categorization will most help technicians select the correct coil? A. Thin coating type. B. Mounting orientation, horizontal, vertical. C. Refrigerant compatibility and BTU rating. D. Brand name and country of manufacture. Answer. Correct answer: C. Refrigerant compatibility and BTU rating. Explanation: ETU output and refrigerant type are foundational to system compatibility. Coil orientation and coatings are secondary and typically adjusted in the field. Country of origin is rarely decisive in field selection. Reference: HRConquer Inventory Systems Guide, ARI Matchup Standards. Question 19. In response to seasonal changes, technician Priya replaces a failed start capacitor in a rooftop package unit. She calls to confirm if a 189-227 UF capacitor is appropriate for motor rated at 145 UF. What should the parts specialist advise? A. The capacitor range is acceptable if the voltage matches. B. The higher range will overboost the motor and void warranty. C. It must exactly match or the motor will short. D. Only dual run capacitor can replace single start capacitor. Answer. Correct answer: B. The high range will overboost the motor and void warranty. Explanation: capacitors must be closely matched to motor requirements. Using a start cap significantly above spec causes excessive torque, damaging windings. Plus, 10% tolerance is generally accepted. Exceeding that risks failure and warranty issues. Reference: NEMA capacitor ratings. CS Motor Accessories Training. Question 20. A detailed analysis of inventory discrepancies reveals frequent issues with part returns due to miscommunication between parts counter staff and field techs. What policy change could most reduce return rates? A. Allowing over-the-phone part approvals only for techs with accounts. B. Requiring technicians to submit part numbers with every order. C. Increasing stocking levels of common parts to reduce delays. D. Pre-packaging kits for seasonal maintenance jobs. Answer. Correct answer: B. Requiring technicians to submit part numbers with every order. Explanation: clear communication of exact part numbers minimizes mispicks and returns. Account verification and kitting help logistics, but part misidentification is the root issue. Training techs to provide accurate data improves workflow and customer satisfaction. Reference: HVACR distribution best practices. HRConquer intelligence modules. Question 21. The effectiveness of suction line accumulators in heat pump systems is critical, especially during defrost cycles. Why is it important that the accumulator be correctly sized and positioned? A. It reduces high-pressure spikes during cooling mode. B. It prevents oil migration during off cycles. C. It avoids flooding of liquid refrigerant into the compressor. D. It ensures balanced airflow between supply and return. Answer. Correct answer: C. It avoids flooding of liquid refrigerant into the compressor. Explanation: accumulators store excess refrigerant during abnormal flow conditions, like defrost or low load, and prevent liquid from entering the compressor, which could cause slugging. They're essential in heat pumps due to frequent reversing of refrigerant flow. Improper size or orientation compromises function. Reference: HRConquer refrigerant piping guidelines, RE 500 foot. Question 22. Under the assumption that a technician replaces a contactor but the system still won't start, which additional part failure should the HVACR part specialist consider first? A. Transformer secondary winding. B. Start relay overload. C. Crankcase heater. D. Low pressure switch. Answer. Correct answer: D. Low pressure switch. Explanation: a low pressure switch opens when system pressure drops below safe limits, often due to refrigerant loss or restriction. Even with working contactor, this switch will interrupt the control voltage. It's common overlooked safety interlock. Reference: NEC 440.4b, HRConquer electrical controls and safeties. Question 23. Through careful analysis of pressure enthalpy charts, a parts specialist helping with troubleshooting observes a system where the suction pressure is high, the superheat is low, and frost is forming on the suction line. What is the most likely root cause? A. Undersized evaporator coil. B. Overfeeding thermostatic expansion valve. C. Partially blocked filter dryer. D. Non-condensable gases in the system. Answer. Correct answer: B. Overfeeding thermostatic expansion valve. Explanation: overfeeding ESVS allow too much refrigerant into the evaporator, leading to low superheat and suction line frosting. The evaporator can't boil it all into vapor. This contrasts with underfeeding, which causes high superheat. Reference: RE Guideline and CSV Troubleshooting Manual. Question 24. When analyzing circuit behavior in a package unit, Malik finds the run capacitor has swollen. The fan motor won't start, though the compressor tries to run. What should Malik do next? A. Install a hard start kit to assist compressor and fan. B. Replace the fan motor with a shaded pole type. C. Replace the capacitor with an exact match enough and voltage. D. Bypass the capacitor temporarily to test load side voltage. Answer. Correct answer: C. Replace the capacitor with an exact match enough and voltage. Explanation: swollen capacitor indicates failure. Replacing it with one that matches both of microfarads and voltage is essential to prevent motor overload or improper phase shift. Bypassing capacitors is unsafe. Shaded pole motors are not suitable for high load applications. Reference: NEMA capacitor standards, HRConquer electrical components guide. Question 25. From a historical standpoint, why are copper and flare fittings still widely used in HVACR despite the rise of press-fit and push-connect systems? A. They are less prone to electrochemical corrosion. B. They reduce vibration better than mechanical fittings. C. They allow precise leak-tight connections for refrigerants. D. They require no torque specifications during installation. Answer. Correct answer: C. They allow precise leak-tight connections for refrigerants. Explanation: copper and flare connections provide durable leak-resistant seals that can withstand refrigerant pressures and thermal cycling, while newer methods of faster flares remain preferred in critical charge control systems. Proper torque and cleanliness are essential. Reference: ASHRAE Handbook. Fundamentals: HRC's pipping and fitting best practices. Question 26. When faced with a call from a field technician requesting a blow of motor replacement, but only providing RPM and horsepower, what should the HVACR parts specialist request before providing a part? A. Wire color coding and phase. B. Nameplate voltage, frame size and rotation direction. C. Motor capacitor size and torque rating. D. Fan blade pitch and belt tension. Answer. Correct answer: B. Nameplate voltage, frame size, and rotation direction. Explanation: motor selection relies heavily on these three specs to ensure fit, safe operation, and airflow direction. RPM and HP are just starting points. The frame size determines mounting, and wrong rotation affects performance. Reference: NEMA motor nameplate requirements. HRC's motor selection manual. Question 27. The foundation of refrigerant controls lies in understanding solenoid valves. In a commercial system, what happens if a liquid-line solenoid valve fails in the open position? A. The system will trip on high head pressure during the off cycle. B. Liquid refrigerant will flood the evaporator during compressor off cycles. C. The compressor will short cycle due to low suction pressure. D. The TXV will overfeed due to upstream pressure surge. Answer. Correct answer. B. Liquid refrigerant will flood the evaporator during compressor off cycles. Explanation. Solenoid valves prevent refrigerant migration when the compressor is off. A failed open valve allows continued liquid flow, causing floodback on restart and risking compressor slugging. Head pressure and TXV aren't directly affected. Reference: Emerson Flow Controls Application Manual. HVACR refrigerant valve training. Question 20. In the modern context of commercial walk-in cooler maintenance, technician Lewis is told to upgrade a split evaporator system to improve air distribution. Which of the following components would help achieve balanced airflow? A. Adjustable blade axial fans. B. Interconnected thermostats. C. Remote solenoid liquid valves. D. ECM fans with onboard controllers. Answer. Correct answer. D. ECM fans with onboard controllers. Explanation. ECM fans adjust speed dynamically based on coil temperature or static pressure, improving uniform airflow. Axial fans are fixed speed. Solenoid valves and thermostats control refrigeration, not air movement. Reference: DOE Commercial Refrigeration Standards. HVACR evaporator airflow design. Question 29. To determine whether a system is experiencing a restricted capillary tube or an undercharged condition, what symptoms should a parts specialist ask about? A. Subcooling being excessively high. B. Suction pressure being near atmospheric. C. Condenser fan running constantly. D. Compressor current draw exceeding FLA. Answer. Correct answer. B. Suction pressure being near atmospheric. Explanation. Both restrictions and undercharging cause low suction pressure, but restrictions may also cause frost at the restriction point. Near atmospheric suction is dangerous, indicating insufficient refrigerant or severe blockage. Current draw typically decreases, not increases, under low load. Reference: HRConquer service call diagnostics. RE 540. Question 30. In summary of HVACR piping practices, why must vertical risers in discharge lines often include a trap at the base? A. To allow oil to drain downward into the compressor. B. To prevent flash gas entering the condenser. C. To isolate sound and reduce harmonic vibration. D. To increase velocity and aid oil return. Answer. Correct answer. D. To increase velocity and aid oil return. Explanation. Discharge riser traps ensure oil is carried with refrigerant back to the compressor. Without traps, oil may collect at low points, risking compressor failure. The trap increases gas velocity in training oil upward. Reference: An ASHRAE Refrigeration Handbook. HVACR refrigerant piping and traps.